We're going to work on two examples of graphing an equation using slope-intercept form, which is y equals mx plus b. So in my first equation I'm given y equals 3 plus 4x. And so let's remember that in y equals mx plus b, the slope is actually the coefficient of x. So that's actually my slope right there. And then our y-intercept is the constant, or b is that constant. And you can think of this because our y-intercept is where x equals 0. So if in this equation we were given, if we were to set x to 0, 4 times 0 is just 0, which would turn this into just y equals 3. So that's another way to just remember where your y-intercept is and where your slope is. So that's b. So I'm actually going to rewrite this in proper y equals mx plus b form, just using the commutative property. You won't always have to do this. A lot of times you'll be given an equation in y equals mx plus b form. Sometimes you just need to use a little bit of commutative property and just switch your terms around. So since 3 plus 4x is equivalent to 4x plus 3, I'm going to rewrite this as y equals 4x plus 3. Again, that's not totally a necessary step, but one reason I do like it is it helps us to really clearly see if we're going to have a positive slope or a negative slope. Like if this had been a subtraction symbol instead of an addition symbol, my slope would have actually been a negative. But it wasn't, so let's go on. All right, so slope. Y equals mx plus b. So in this case, my m is 4. So that means my slope is 4. And it might be helpful while you're getting used to doing this if you always write your slope as a fraction. So even if your slope is an integer, like mine is, my slope is 4, write that as a fraction. So instead of just writing 4, I'm going to say 4 over 1. Because our slope is our change in y divided by our change in x. And so if I write it as a fraction, it will help me remember that in this case, I'm going to be going my y's, I'll be going up 4, and then to the right 1. Okay, my y-intercept. Y equals mx plus b. My y-intercept is b, or that constant. So in this case, my y-intercept is 3. But not only is it 3, but it is the point where x is 0 and y is 3. So remember that 3, or that value in the b place, just tells you your y point at the y-intercept. But your x is always 0. All right, let's get to graphing this. So first step, I'm going to graph my y-intercept. So my y-intercept is at 0, 3. So that would be right here. There's where x is 0 and y is 3. Now I can use my slope to show that I'm going to go up 4 and then to the right 1. My change in y is positive 4, so I'm going to go 1, 2, 3, 4. My change in x is positive 1, so I'm going to go over 1. And my next dot is going to be right there. And so I want at least 3 coordinates planted. So if you run out of space and you can't go up anymore, let's also remember that since my slope is 4, negative 4 divided by negative 1 is also positive 4. So I can also go down 4, 1, 2, 3, 4, and to the left 1, that was negative 4 divided by negative 1 equals positive 4, and land a dot right there. I could do one more too. Why not? We have the space. Let's go down 4. So I'm just going to Let me get that red out again. Go down 4, 1, 2, 3, 4, and over 1, over 1. Plop another dot. Okay, and then we will connect these points. So, this is not always my strong suit. That's a pretty bad line, but you get the point. Ha ha ha, I get it, you get the point, but boom. All right, and there is my line of y equals 4x plus 3. Let's take a look at another one. Let's take a look at y equals 5 minus 5/4 x. So here we are again with a situation where I need to rewrite things. So I didn't give myself space to do that here, but I'm just going to do it like that. You would be doing this in your notebook. So I want this to be in, whoa, I don't want that to happen. Come on back, you guys. Come on back, don't be leaving me. I want this to be in y equals mx plus b format. So we're going to say y equals mx plus b. So I'm just going to use the commutative property and just shift those around. Now let's remember that subtraction is not commutative, but addition sure is. And so if I think of this instead as y equals 5 plus a negative 5/4 x, then I have addition and I can swap my terms. So I'm going to go ahead and do that. Let me give myself some space here. And I'm going to rewrite this as y equals negative 5/4 x plus 5. Which means my slope is in that m position. So my slope is negative 5/4. That means I'm going to go, so my change in y over my change in x, that means I'm going to go down 5 and then to the right 4. This could also mean that I'm going up 5 and to the left 4. As long as they are opposites. As long as it arrives at a slope of negative 5/4. Right, my y-intercept is that place, that B location. So in this case, my y-intercept is 5, or more precisely, it is the point 0, 5. Let's graph it. So 0, 5 is right here. And if my slope is 5/4, let's start with a downward motion. Let's go down 1, 2, 3, 4, 5, and let's go to the right 4. So we go 1, 2, 3, 4, and we can plant a dot right there. There's my next dot. Let's make another one. So again, I'll go down 4 and to the right. Down 5 and to the right 4. So I'll go down 5, 1, 2, 3, 4, 5, and to the right 4, 1, 2, 3, 4, and plant another dot. If I wanted to go up, I could. If I wanted to instead go up, I could, from my starting point, I could go up 1, 2, 3, 4, 5, and then to the left 4. 1, 2, 3, 4, and there'll be another dot on my line. So as long as you are going in a motion that equals a slope of negative 5/4, you're going to be okay. My favorite part, let's connect these dots. Let's see, this one's turning out okay. That That is a halfway decent line. Good job, self. All right, your turn to give it a try. Let me know if you have any questions.